Hello, check. Hello, hello, check. Hello, 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 check. Hello, hello, check. Hello, check. Hello, hello.
Hello, hello, hello. Check. Good morning, everyone. Please take your seats. Good morning. Today is the day 2 of the 48th GSP Standardization Series meeting. We are starting with the session 1. I request Colonel Pratap Singh Rao Rane, the chair of this GSP invited session 1, to please come on the dais. I request all the speakers of this session 1 to please come on the dais. Aradhana Deshmukh, Mandar Biwalkar, Nandakumar Kulkarni, Jyoti Gangane, Vivek Kumar. To start with the proceedings, uh, as a trustee, KIT, Colonel Pratap Singh Rao Rane is the chair of this session. I request our trustee, Shri Bharat Patil sir, to please come on the stage and felicitate Colonel Pratap Singh Rao Rane. Thank you, sir. I request Colonel Pratap Singh Rao Rane to start the proceedings of this particular session. Thank you.
Good morning, everybody. It is my honor actually to talk in front of you, the technically ignited minds, and again in front of Professor Ramji Prasad. Why I am here as a chair, just I want to tell you, because you must be seeing me as a colonel only, that is the Fauji. But I was in Corps of Signals, which handles the defense communication, the cyber warfare and the electronic warfare. So that's why I am here. And after a stint of 25 years in defense, I was head of the software quality assurance of the ethical company of India, Tata, for 9 years. And then I left and now I am retired, doing everything for KIT now. So when Professor Chauhan told me that you have to talk something, so actually it is my heart and soul, communication. But the problem of all this wireless communication, what we face in strategic communication level, all defense communication is strategic. If communication is not there in whatever form, any forces of any country cannot move ahead. Any operation cannot be planned. And to have a proper strategic communication, we have to have a quality communication. And this quality part is missing everywhere. All manufacturers, see, you technical minds, researchers, do your job. You give us the research technology to manufacture or to the use of the users. But the quality part is totally missing while it is given to the users. Now generally what happens, majority of the population thinks 5G, 6G, all these are only for mobile communication. That is our mobile. No, this 6G, 5G with the greater speeds and whatever technology is developed by researchers and technocrats like you, with all this OFDM and now that SC OFDM and your DFT OFDM which is coming. With that, security part, it's one of the dimension of the quality, which is at most the requirement of all strategic communications. Now, I have just focusing on defense because I am from defense. And what I have faced in defense as a user and as a manufacturer and a supplier to the defense when I was in Tata. So, such points I'll be discussing with you. And you are free to ask me anything. It will not be only presentation. I generally flash the slide and speak everything else other than the slide. You can bring me back to the slide by asking questions. So we'll start with this. Now what is quality? मेरे को quality product चाहिए मतलब what you want? Communication में quality चाहिए. Can 6G and 5G give me quality? Yes, it will give higher speed, with higher bandwidth, with much more orthogonal multiplexing and all. That is okay. But does that mean that we will have subscriber end quality here? And one of the important aspect of that is security. How will you ensure that? Now, security and quality does not mean that only communication, media will have these things. We should have the holistic approach, that is system approach. If media is secure, but your subscriber and devices are not secure, what is the meaning of the security then? Which leads to the poor quality to the users. And now you are seeing, any software we are downloading on your mobile, it asks everything, allow, because we want to use those software for those social media thing, and we give all the permissions to the that software. Then where is the data security there? And then we harp upon ki yes, data is leaked and my account is hacked and all. So this is what our thought process of quality is totally different. No, it is not different. It is wonky. We don't understand what is quality. We just speak about the quality. That's why I chosen this subject with the concurrence of Professor Chavan. Now, in this, quality of software is much important or quality of hardware is important. Now, the Japanese say, go to Gemba. What is that Gemba? Gemba is shop floor. You go to the shop floor, you will find the defects. Why? Because they are visual. But if you go to Gemba or anywhere, software is invisible. And everything is now governed by software. So now, and the communication softwares are again very complicated due to their nature. So quality of software is again important along with HQA, that is hardware. Because electronics is again hard. We forget electronics, we forget mechanical, the form factors of anything. We only talk about the software. And that's why it is mad rush towards the computer science and engineering. But actual heart is electronics. And so it is a hard, it is vulnerable to all the vulnerabilities available in the environment, as well as in the software, as well as in the hardware. So it is very dependent and has to be taken care of with the proper quality procedures. And for all these, there is a term coined by all the technocrats whenever you go outside to the quality. Incidentally, I was working with DGQA also, Director General of Quality Assurance, as well as MEIT, Ministry of Electronics and IT of Government of India, to formalize the methodologies for the software quality assurance and hardware quality assurance for the communication systems. So we have given some drafts. You might not be knowing what is already available in Indian context. So that I will tell you. Then you can use that platform to jump on these communication qualities. It is just recap what we know in the classroom, what we teach as professors to the students, and as researchers, what we know is this. It is a fitness of purpose. Quality मतलब मेरा जो काम है वो होना चाहिए और ठीक ठाक होना चाहिए. That is our understanding of quality. But now must. Yesterday, I don't know who all have visited our that Idea Lab, and the other one is content. Content development. There, with our that Idea Lab, they have, I think your people have put their, manufactured those antennas. Now, antenna design is very, very critical. It is not that easy to design a antenna for a strategic communication. And all communication are strategic. We have seen, if my son has gone out and he has not replied to my call, my anxiety level increases at such level, I am so irritated, I start shouting on anybody in front of me. That is the power of communication. So you have to be in communication, and that too a quality communication that is secure and best communication in my context. So that is what is communication, and how to get it, I am telling you. If you have any point on this, you can immediately stand up and ask me, because there will not be any time for question and answers, because all these guys have to speak. So this why they are, you might be knowing now, only what we do, that new term which is agile. What is agile? Agile systems. You must have heard this agile system, agile framework, Scrum Master and all. What they do? The quality procedure time is reduced to throw out the products to the people. So whenever time is reduced, actual time is reduced, you have to, the quality is hampered, whatever you may say. And only functional testing is done there. So these are the new functions required and these functions are given. So that is what is agile. In defense, agile is not, don't follow agile methodology. This is our understanding or our requirement of quality. Communication should be correct, reliable, efficient, portable, usable, reusable, and maintainable. All these communication systems should be like this. Now, how to ensure this? हम तो लिखते हैं, बोलते हैं, but how to do this? कोई नहीं सिखाता ये, and हम सीखने का प्रयास भी नहीं करते हैं. Why? Because we have not understood or understood the meaning of quality in other way. Now this is the scenario, simple defense scenario of a strategic communication. All these red lines are communications. You may not be seeing it, sorry. Okay. This is a very simple scenario. I am just giving the formal tactical communication. The green lines are coming from AWACS. You must have heard early warning systems mounted on a aeroplane. All those missiles and sea and ground forces, all these are dependent on communication, and that too wireless communication. Because who will provide the OFC there or any type of line communication there? Nobody. And in quick time only wireless communication is available. And whatever is in air, free air, is vulnerable to catch. So whatever I'll be telling can be hacked. Now you understood the importance of communication. It is not only mobile. This is what is communication. And I have not shown you the actual strategic communication, which is the back end for these forces. Now, yesterday, Dr. Arpan Pal was also saying, some other speaker also was mentioning about the sensors. Now it is very easy. We have put sensor there. Who will communicate with that sensor? Sensor से data लाने के लिए या interact करने के लिए what is required? Communication. It is wireless communication which is required for all the sensors now. And those, you have seen those drones and all, attack of drones, वो film में देखना अच्छा लगता है, but the control of that wireless sensors is again a major problem. Only ZigBee protocol is not enough to handle the drones. That's why that EMBB and all, I'm not going into the technical details, but it is there. Now this is what we have studied, simple communication system. Basically, it is, I have made it slightly complicated, but it is simple. Transmitter, media and receiver. Transmitter ke pehle information source and there are the destination users, correct? This is the simple. Now, what is the two major parts of it, hardware and software? Now how to ensure the quality? Now what is happening? Now electronics, जो saffron color में रखा हुआ उधर, electronics. What I am telling you, heart of communication or heart of everything now. There is a hardware quality assurance for electronics. There is a EMI EMC. It is again neglected part. Have you heard about EMI EMC, na? Electromagnetic compatibility and electromagnetic interference. Two electronic systems or electronic systems are working together, it bound to have the EMI EMC problems, and which can send the garbled messages which are incorrect messages to the user, then in strategic communication it is not acceptable. So that is what. Then you must have heard that C marking, which is a safety. It is not security, it is a safety. And there are static charges. You must have seen ki, whenever you do something on wool or your body also have the static charge. This can hamper your handheld devices. So that is what. So all these tests have to be done in the quality assurance of the electronic and mostly communication devices. Secondly, what is the hardware quality assurance then? See, anything, any electronic piece have to have the physical security that is provided by mechanical engineers in that form factor and your, what you call, various alloys and thickness and all, which cannot pass the humidity and shocks, pressure waves and all. So that is, it's a major issue. Whatever I am telling you, pressure, vibration, temperature, humidity, you can have a doctorate in each of this word. That is the depth of that hardware quality assurance of any communication systems. And the other, those are the environmental parameters, what I was telling you, the temperature, humidity, vibration, all this. And this mold is again very important. Any part you fit in, whether it is a plastic or a rubber, whatever combination is has, even your connectors, mold growth will happen on that. So that is again, we send the bacteria and various chemical compositions to see that whether it sustains. And then comes the software quality assurance. Because whatever communications that is radios and transmitters we have, those are software defined now. So these telecom softwares are again important, and that is the again critical part which is totally neglected. Even in Tata also, it was totally neglected, software quality assurance. You have so big test procedures for that saffron part and this part, yellow part and saffron part. But there is nothing on green part, because it is invisible. Kaam karega wo. But that is the most important part now, communication softwares. Because whatever scheme you have, OFD, multiplexing karo, modulation karo, or frequency hopping karo, which is needed to avoid the jamming of those waves. So it is done by software. So who ensures the quality for that? Who tests that? So that comes under software quality assurance. And the term which is coined is verification and validation. So this is only I have added whatever written in there, the reliability. Now what is reliability? हम बोलते हैं ना कि system should be, communication should be reliable. How you ensure that? How you define the reliability? Simple word, लेकिन बता नहीं पाओगे आप technically how to make it reliable. Because we have not thought over that. Now 6G and beyond we are going. But how to make it reliable? What are the parameters of reliability? So my lecturer friends, professor friends here, they will tell me, because we teach in college the MTTFM, MTBR. Those are just parameters. How reliable you make it. How a protocol, which is, incidentally you may be knowing protocol. It is the understanding between two communication systems. What is the protocol between me and you? I should talk in the language you understand, and you should talk in the language I understand. This is a simple protocol. But how to ensure this? I, as a communication system, in talking in same protocol with the other system, and that system it is understanding it. So those are, and it is done by software again. So how to do this? So it is the part of software quality assurance. And Professor Ramji Prasad, and yesterday somewhere he was mentioning about the standards, the standardization meeting. Now, standardizations are two meaning. One, you follow the standards, make standards for everything to follow. Why standards? I will tell you in next slide. Other is the standardization, to make a level field. Otherwise, the monopoly of one manufacturer will be there. If simple, your credit card is there, IR credit card, it has 6800001 standard. What it mention, आपका उसका जो इलेक्ट्रॉनिक पार्ट किधर होना चाहिए, उसका डायमेंशन क्या होना चाहिए, so that the manufacturer of that card reader or IR reader have level field, monopoly नहीं रहेगा. So that is one meaning of standardization. Other meaning, make every process a part of standard. So that is again standardization. So there are two meanings, what yesterday Professor Ramji Prasad also mentioning. So now why standards? We are, I don't know about the foreigners, but in India we are very reluctant to follow the standards. जहाँ standard आता है वो कौन करेगा? And all these duties, rules are part of standards. जहाँ rule आता है हम generally हमारा पहले क्या होता है? नहीं करेंगे. क्योंकि वो it has its overheads. You have to do certain things in certain way only to achieve the desired efficiency. That is the meaning. But we generally, हमें जो अच्छा लगता है वो करते हैं. Efficiency का भी मतलब ही नहीं है. But in communication, it will not work. We have to have efficient communication. Now, our requirement is that usability, it should be usable, functional, and secure. These are three basic requirements of any communication system. How to achieve that? You should have discipline. First and foremost is discipline. Now that discipline is not the army discipline what we have, it is the communication discipline. How it can be achieved? With the proper command and control. I am using these layman's terms so that you can understand. There are various technical terms for this, command and control. You have the access control and your administrative powers to a particular piece of software, so that other cannot meddle into it. So that is command and control. To achieve discipline, we have to have command and control. And to have command and control, we should have defined matured processes. अगर process ही ठीक नहीं तो आप command and control क्या करोगे? अगर in that process I have not written down कि Amit Deshmukh should behave like this or this communication system should behave like this, तो आप check क्या करोगे? आपको क्या पता है उसमें? आपको पता ही नहीं है communication system को हमने क्या behave करने के लिए बोला है, तो tick off क्या करोगे आप? So that's why there are processes. Then these processes are there. In present context, they are working or not. So there is a review. Who does that review? Whether the user can do it, some boss can do it, or third party can do it. There are different connotations for that. So those reviews are there. And for all this कि ये सारा हुआ है, करना चाहिए, and then we will achieve this command and control and discipline, we have to have the documentation. सबसे tedious part है, what we do in colleges, NBA and NAC, lot of documentation we have to do, and we don't do it regularly. That's why last 1 month में हम पूरा 24 hours काम करके वो documentation करते हैं. It has to be followed regularly. That is what is discipline. If you are not doing regularly, that means you are indisciplined, which is not acceptable in communication systems which are strategic. And for all these process, we have standards. You must have seen that standards 9001 and 9001 2015 basic standard जो सारे accredited है उसके लिए, उसमें क्या है किसी को पता नहीं है. So it has the set of processes, set of reviews and everything. All standards have. They are very difficult to read but very easy to implement if you understand. So what different standards we have? Process standards, product standards. Process standards, private standard is there, process standard, which is that commonly used outside CMMI. CMMI level 5. Sir? I thought he is talking to me. No. I was very glad that somebody is awake and talking to me. Process standard like CMMI. There's a product standard AS9100D. You must have, I don't know, you have heard, but you should talk in these terminologies. Then your counterparts, that is manufacturer. See, what you do research and publish papers and work on innovations and technologies, finally our aim is that should be used. So how they will use? If you talk to them, your technology, or present your technology in their terminologies. Break even, ऐसे कुछ बोलने से उनको अच्छा लगता है. We don't know what is break even, but they understand break even. ये process का break even क्या है, उनको बताना है हमने. So you have to present your technology in their context, basically. So these standards help you in that. Then there are QA standards. The big companies have their own QA standards like Tata, L&T, they have their own, because they have evolved manufacturing processes. Industry 4.0 is just a term coined by the manufacturers to bluff you. Actual QA is not happening there. They are having QA standards for that. That you have to match with that इंडस्ट्री 4.0. अदरवाइज हम बोलते हैं हमने तो कंपनी 4.0 लगाया, क्या है उसका मतलब? फाइनली वॉट एवर प्रोडक्ट यू आर जनरेटिंग और मैन्युफैक्चरिंग हैज टू सेटिस्फाई द यूजर्स, अदरवाइज व्हाट इज द मीनिंग ऑफ दैट? एंड if it is satisfying, then only you will generate the revenue. Any business, Tata, anything, they are not for charity. They have to generate the business, money. So they have to do that. So to generate money, the most easy part is to reduce the time for quality. Then there are testing patterns like 29119 ISO. These I'm talking about all international standards, not the. That is the only standard, incidentally, for software testing. That is 29119, 2013 का latest standard. Then your telecom standards are there. TS. देखा है ना हमने? There is a 3GPP group which is working on communication security, specially. So 33.117 is the security standard. I think हमारे कॉलेज में मैंने बताया हुआ, I don't know, the reply is not there. So that is, आपको या किसी को तो बताया था मैंने. So those groups are working on these standards so that our life will be easy in communication field. And what Indian government, that MEIT, our group has done, I will explain in the last slide on this TS. And there are security standards. Security is very common word nowadays. Security चाहिए, लेकिन क्या चाहिए हमें नहीं पता है. वो security कैसे चाहिए? Anybody tell me what is communication security? क्योंकि secure communication secure चाहिए, मतलब क्या चाहिए आपको? Nobody will be able to tell. And security is a word which has a lifetime. Any system cannot be secured lifelong. Time is there. One-time password is one type of security. It is just for one click. Such types of securities are implemented in communication systems. And in strategic communication, it is very important to change these security mechanisms. Otherwise, you will be hacked. Same thing happened in the power. There are two in power sector, which is again strategic sector. There are two networks always. One is power network, one is IT network. If IT network is hacked, power is gone. Grid failure मतलब क्या होता है? Power cut नहीं करते वो. IT network is hacked. And IT network is hacked if you hack communication system. That's what I'm harping at. It's very important. And this is the software. All these things are driven by a software which is totally neglected. Everywhere you go, anywhere you ask for software quality assurance, or what you are doing about the software which is residing in that chip, nobody knows. Simple thing, we purchase chips which has BIOS. BIOS is untouchable. No manufacturer will give you BIOS. They can put anything in BIOS. Then we say, वो Chinese, उसमें लॉजिक बॉम्ब है. क्या होता है लॉजिक? BIOS उनका hampered होता है. But now Indian defense asks the chips with BIOS. We have to have, otherwise we reject the chips for our systems. And only one company, that is Germany, which is giving it 8 times, at 8 times cost, small chips. So that is what is the quality assurance. This is book. What is SQA is in book, your software engineering book, you will get this definition. What is important is, it is not only testing. What you think quality is testing, no. It is auditing also. Because we are following some standard to achieve something good. So those processes have to be audited. Same thing, income tax. They audit our incomes and all the things. Na? So they have their own standards. Similarly, quality has their own standards. So auditing plus testing is your, and then quality is assured if you do this. This is VNV, you must be knowing what is VNV, because this, why I have put this term, because it is commonly used. उसका VNV करा लो, मतलब क्या करा लो? बताने वाले को भी पता नहीं होता है, करने वाले को तो पता ही नहीं होता है, what is VNV? तो जो सॉफ्टवेयर, जो CSC वाले बच्चे बैठे उनको पता होता है वो, verification and validation, because they have read this in software engineering book, or their lecturer must have told them what is verification and validation, but how to implement it. So that is the part. Now, hardware, these terms I have just mentioned, ESS, PAs, QT, AT. These are the set processes in any big company. ESS is environmental stress screening. Any system, subsystem, have to undergo a temperature and vibration cycles for their, for its, your PCB and all, they have to go through, once they are in, they are part of subsystem, they have to go through these ESS. It is 100%. 100% in the sense, it has to be done on 100% numbers. Whereas this QT can be done on sample. There are various sampling standards available also. It is again acceptance test, what we do. कोई भी टीवी लेने गया, कैसे accept करते हो? You see their quality and all. मतलब it is general, I'm telling you. So it is what a user perception of the product. That is that AT document, acceptance test. That was in all in your hardware quality assurance. But what about software? हम कहाँ टीवी का सॉफ्टवेयर चेक करते हैं? Not, we don't even check the response rate of the TV. हम सिर्फ प्राइस चेक करते हैं इसका. सेम टीवी है, इसका ये क्यों महंगा है? It is based on all other qualities of your electronic system. Now this is, again, this IV, I want to tell you, most of the government tenders will have this IVNV. Independent verification and validation. Just like you might be knowing this, you all are researchers to random number generation. But there is no random number available in nature. It is all PRN, pseudo-random numbers. I don't know whether you have studied this statistics and all to model something. Incidentally, I have done I am MTech in modeling and simulation, so my mathematics and statistics is very strong. That's why I'm speaking this pseudo-random numbers and all. So Just like that, independent, you cannot have independent V&V agency anywhere in the world. Because to appoint an agency, you have to give the funds. Funds are not given by the indentor. They are always given by the supplier. तो supplier ने पैसे दे तो वो बोलेगा वो clear कर दे. That is what is happening. This is just bookish knowledge, difference between software quality assurance, because in my total this 40 years of career, I am still finding, I am not found out any person at the first instance can understand the difference between software quality control and software quality assurance. That's why this is the difference. Major difference is your process and product and detection and prevention. हम बोलते तो है prevention is better than क्या बोलते हैं वो से. Now any testing, whether it is conventional in software, conventional is functional. We have to generate a negative testing. I don't know you have heard this or not. And in communication, it is the most important testing, which are non-functional requirements. Simple in data communication, we have this software which generates, which asks you the password, है ना? Username and password. This is the security mechanism of that particular software. Then how to define that? How to test it? So only a password, username is standard, will have at least 26 test cases for this. Suppose password हमने डाला कि it should have 8 character length with 4 numeric, और first डालते हैं ना, सिर्फ 4 numeric डाला हमने अपने सॉफ्टवेयर में. You can test 8 numericals at 8 places. Then you can try with gap, space between 2 numericals. You can have explanation mark in 2 numericals. You can have character first. You can have control and numerical first. These are all test cases. This is called negative testing. And if a software replies to that, then it is a good software. If it goes in hiding or that, what do you call that, core dump happens, it is bad software. And which is happening because nobody tests, going into the details of negative testing. Now, this is one more thing. All telecom softwares are very complex. So what we do, उसका automated testing करवा लो, वो Selenium use करवा लो. ऐसे बोलते हैं ना, you must have heard this all automated testing. Automated testing is not the solution for any type of communication software. Only it can be used to test the robustness of the software. That will next. I am taking ज़्यादा time ले रहा हूँ क्या थोड़ा सा? अभी chance मिला है तो I was a lecturer incidentally in my early days, so I am utilizing that power now. 5 minutes, yes. So what is automated? Why automated systems are preferred? Because we don't want to do anything. वो करता है वो अपने आप ही software and result देता है, we are happy, it is pass and fail. Actually, what I'm not getting that word. What any software tool or anything which is developed in communication software also, it has to have the some assumptions, and those assumptions are left unattended. So those are not tested, and those assumptions which are not tested will be problem करता है actual communication में. And the analysis of reports is important thing. Tool will give you 10 pages of report. You will not be able to analyze that unless and until you know the architecture of the software tool. These are the softwares, you know all this. Now I'll directly go to telecom testing. Now why telecom testing is important? Because the complexity of the software and the systems, basically, receivers and transmitters. So these 3 major parts are there. you are functional, what you do with the agile and all, जो चाहिए वो मिल रहा है हमें, जिटर कितना है वो कर सकते हो आप, कॉल ड्रॉप नहीं होना चाहिए, दैट यू कैन अचीव, जो QoS पैरामीटर्स जो बोलते हो आपको. Now conformance, what I was mentioning, the protocol, you must, you have told it should be in certain protocol, suppose IP, TCP. You have to ensure that protocol between the two systems is the same and it is working. There are tools available for this, which are so costly. Around 2 crores का एक tool मिलता है उसको Defense 6 का, to check the protocols. And the same tool checks the protocols and induce the one bit different in whole that stream. If you put one different bit and the receiver, if it detects it, then it is a robust system. Most of the system do the core dump. So those are not robust systems. So these are the main parameters of the telecom testing. These are the standards what I have mentioned. Now whole world is testing the your communication system on common criteria. I don't know whether you have heard this name. Common criteria is this international standard for testing the products. We test the functionality and the security with various EALs, evaluation assurance level. There are from 1 to 7. EAL 4 is the ultimate level. And India is now capable of doing EAL 4 testing of the telecom systems. Presently it is done only in STQC, Kolkata. But Indian government has already initiated a scheme as a TSTL, Telecom Security Test, Software Testing. 15408 standard is common criteria standard for telecom security. Rest 17025, you know, 17025 is for lab management and all. NABL uses this. All labs basically uses 17025. This is the government initiative. We have NABL body. Till 2013, NABL does not have IT part into it. It accreditates the labs for 17025. But now they have started with our recommendations of MEIT team. Now they have started to give the accreditations for IT also. And they have chosen the 29119 standard, testing standard for IT, and 12207. Now this ITTL is a part of STQC, again Department of IT. It is some different team to ensure the products which have software and electronics. Now this is important, TSTL, this is totally for telecom, which is initiated by our Ministry of Communication, DOT, and they are doing fantastic job. If you get some time to visit DOT Bangalore, where the special cell is there for telecom testing, and your TEC labs at Delhi, then you will understand the volume of telecom software testing and how they are handled, because they are so complex and important. So those standards they are using 33.117 and all. You can go through this. Why I am mentioning A2LA is we were dependent on American Association for Laboratory Accreditation for Communication Softwares and IT before 2013. Last slide. Sir, काफी बोर हो गए मेरा सुन के. Sir, thank you. Hello. Now I request Aradhana Deshmukh to give her presentation.
Good morning, everyone. I said all the students, good morning. Thank you for the response, and thank you very much, KIT team, and of course, my guru, Dr. Ramji Prasad sir. Thank you very much for providing me this opportunity. Yeah, already sir has already explained there are various challenges in 6G. Obviously, we are already there in a 5G, but still there are various challenges, and these are broadly categorized into three. That is architectural challenge, technological challenge, and social challenge. Out of that, my PhD work mainly on service level agreements, and that will be the first kind of its challenge under this architectural challenge. Obviously, in 5G or in any kind of service level agreement, what will be the scenario for 6G? That will be the first challenge, and that's why SLA and low latency, these are the two basic challenges in front of the 6G. As we can say, we are moving from any Internet of Things to Internet of Intelligence. And for that intelligence, again, we have these technological challenges, which is based on frequency expansion, radio wave usage expansion, and frequency utilization. But all in these particular challenges, we can broadly compare 5G and 6G based on these basic criteria, that is the data rate. Obviously, will we have 100 times more data rate will be available in 6G, as well as the reliability and latency will always consider for the 6G. But out of this, what will be the computing power? Because right now we can utilize that cloud computing. Yes, the cloud computing provide many used to technologies for any common man. So out of this comparison of 5G and 6G, we have localization precision. And for that localization precision, we have to think for computing. Because in all these categorization or comparison, we are not concentrate on what kind of computing will be available. And that's why after PhD, I concentrate on the computing word. And that's because of that, yes, this will be the future 6G 3D model is standardized by our Dr. Ramji Prasad sir and all the standardization forum in last GISP meeting. But in this particular 3D model, you will find that again the main word is missing, that is the computing. We can say, yes, we have this high speed, we have this latency, we have this 6G application, and the two things that is we'll have to concentrate for computing, that is concentration on medical services, any kind of services. So we can say Internet of Service will be available in 6G. And for that, we need the support of computing power. And I concentrate on the word that is a computing. So during these next 20 minutes, this will be the pathway for my presentation. And I concentrate the computing with addition word, that is the quantum. Yes, we can see high quantum programming languages, and technology change impact, as well as with her references. So in a 6G, obviously network intelligence is totally depend on a single word, that is the quantum computing. Quantum computing is the use of quantum mechanics. So obviously we'll have to go long back, because this word we already started in physics and mechanics also, and we can say it is to perform the computation at much faster speed. So when we can say 6G is the much faster, so we have to concentrate on this quantum computing. And that's why I started my research again after PhD with this particular two words joined together, that is the quantum computing. Why? Why we need and what will be the utilization of this quantum? This quantum computing is applying start from the scratch to the application everywhere. We'll have to go long back in the 9th century. This is quite religious, but it's true. In 9th century, there was again the three basic tantra, we can say, that is yantra, tantra and mantra. Since from 9th century, this Borobudri, that is the first Buddhist temple which is available in Angkor, still now it is available, and the complete statutory is depend on quantum hardware, that is yantra, quantum algorithm, that is tantra, and quantum operating system, that is mantra. That's why I said when we go for this 6G, definitely we'll have to concentrate on this quantum computing. Out of this, we'll have to concentrate on quantum hardware, because yes, the speed is available, wavelength is available, spectrum is available, but we need the basic device, and that device should be quantum. And I concentrate on this yantra, that is quantum hardware. So when we apply this quantum computing to the processor, then it will be truly standardized. That will be for this 6G spectrum as well as 6G hardware. So the classification, right now we are utilizing this classical computing. Classical computing have 1 bit, and obviously the quantum computing, that is the qubit. So this is the basic difference. We can start from computing, or we can apply from the processor itself. So from the device to wavelength, everywhere we can apply this quantum. In a second difference, that is, we can apply the number of simultaneous calculation. Up till now, in a classical computing, it is a single bit, and obviously when we consider for this quantum, it will be multiple. And that will provide you the real speed and the support for the calculation. So here, the further difference, that is information behavior, noise tolerance, security, and computation. See, all will be covered with a single word, and that is the quantum computing. And obviously, since during these 2 years, I received one of the important paper which was again published by our Guruji, that is Dr. Ramji Prasad, in 2021 with another researcher, and which is 6G for this quantum computing. And I realized that my research was in the right track, because it was standardized by my Guruji. Thank you, sir. Yeah, based on that, we can say that how to apply. See, up till now we can say it is a quantum. So definitely we'll have to start with the ICs, and ICs with a quantum processing automatically increase the speed of computational power. Yes, with the basic modules, if we go previous to that, yes, it is depend on the basic modules, logic gates, and the transistors. So where we can apply? We can apply with logic gates and transistors. So this quantum mechanics we can apply with these logic gates and transistors. So obviously, when we consider for this computing power, we'll have to believe on this Moore's law, because obviously Gordon Moore was the founder of this Intel. And if I ask any one of the student that what will be the long form of Intel, anyone tell me long form of Intel? Long form of Intel. You can Google it now, forget it. Intel is an integrated electronics, and which was founded by and started by Gordon Moore, and every 20 months you will get a new processor. And based on that, obviously, this is the based on Gordon Moore. So this, I like to suggest, during this 6G devices computing, we'll have to apply this quantum computing. So it can apply with advanced technology in making devices smaller and smaller, and obviously nowadays 1 TB hard disk is very easily available with all of our processors. So quantum computing is already started applying with the Intel and for the basic gates. So this transistor size trend was again mentioned here. If we check the transistor size, it is in a nanometer, and we'll have the detailing of that. Again, the average diameter of any atom from 0.1 to 0.5 nanometer. So these are the very basic details about this applying Moore's law in a computing power with a quantum. So this is the conventional bit. We are thinking on that for the single bit. And now we are changing this 0 or 1. So these quantum bits are changing continuously. Why? It is a multiple bit. It is supporting with a multiple bit. And that's why this 0 and 1, both the signals received at the same time, and which will increase the computing power for the calculation, and definitely the 6G devices will also required based on these qubits or the quantum bits. So how it is works? With a very small understanding, it is mainly work with a 2 raised to n power. That is, when we have 2 qubits, 4 convention bits will be available, and obviously 4, 5 and more than that, it will conventional bits will be 32 bits. See the difference between the simple computational and the quantum computational. So obviously 2 raised to 300 will be as equivalent as particles in a universe will be available recently, and obviously after 20 months you will definitely get a new quantum processors. So what will be the review questions when I started my research on the quantum? These are the, so what are the different types of programming languages? Because everywhere assembly language program is always the challengeable language, and no one will understand that. So what will be the programming languages? Which quantum programming language are used mostly? What are the advantages and disadvantages for this quantum programming language? And the personas that require the quantum programming. So obviously when the quantum computing is there, we have to think on the quantum programming. And obviously these are the typical parameters for this research kind of view. That is again the evaluation criteria, what are the different programming languages, quantum program, and what are the software development kits are available. Yes, everything is available with a combination of Microsoft and Intel. So this is the summary which I have done up till now. That is recently one of my paper was also published based on this quantum mechanics for applying network intelligence. See, up till now I use the word for this individual machine, but now we can apply with applying with network technology. We'll have to consider all these languages, because we'll need the programming language to do all such communication or any further process. So these are the typical paper summary, and that quantum gates are depend on the few criteria, that is the Pauli X, that is the NOT, Pauli Z, Hadamard, and C0. These are the basic changes was done by the Intel for increasing the computing power. And this is the small circuit where the multiple signals can be controlled with this quantum. So as I told you that obviously for 6G application, we need the devices, we need the wavelength, we need the transmitter, receiver, and end user. So for everywhere, we can apply these multiple signals together. And obviously, these many X gate, H gate, CX gate, these are the basic functions applying with a single bit. So this is the first innovation was done. It of course by the Intel and many other manufacturers, but now we are moving, the hardware is ready, now we can apply the algorithm. My basic degree is computer engineering, so obviously I am interested with this quantum algorithm. So how it works? So when I again searched it, and I got the references as the quantum languages based on our own language, our own old language, that is the Sanskrit. And still today, here you will find that QSAN gate, that is quantum language for evaluation, is completely depend on Sanskrit. So those who really understand the Sanskrit, they are really very easy to do the programming. And I'm proud to say that this Gen 4 quantum presents this first mapping Sanskrit with a quantum language. and that is the QSUN gate. And this will provide you all the communication as well as all the simple TCP/IP design as well as TCP/IP chat, TCP/IP communication. Everything was established using this QSUN gate. At the same time, see for example, where I started my research and what I have done. I have done all this with a open source software provided by Microsoft. This is again the very good challenge for the Microsoft. Otherwise, Microsoft are always paid and copyrights are there, but still, those who are really interested what is going on in the quantum, you will get this QC kit, and this is the small program which will provide you simple NOT gate with a multiple input and output. So here it is a small Q hash. We called it as a Q sharp. This Q sharp language, which is quite near or the combination of assembly and your regular software programming language. As we all are very used to for the Python, but at the same time, this Q sharp is again provided for all kind of communication standard protocol design and testing. This Q sharp will provide you all such kind of flavors for the testing. So these are the languages recently available. Out of that, we can say that quantum software development, this QSUN gate is also supporting for this functional language or the functional programming language, because that is the main required, and it is also applicable for these informative languages. So this QSUN gate is, or the Q sharp is also supporting with these three flavors together, as this is the quantum, and that's why this quantum is applicable from manufacturer to application level everywhere. So these are the imperative languages, because they use the programming paradigm based on the idea issuing a set of onwards and the commands and the instructions. So those who are really Python lover, they can really easily understand this Q sharp too. So we are moving that here the technology change, because here the actual programming or the actual executables are available, because see, we can easily update our open source language, either Red Hat Linux or Ubuntu, but we are not able to change the Microsoft operating system. But this is the real support which will allow you for changing of any kind of computing. So obviously that will be the major impact on the organization, which will provide you the resource hiring very easily, and that's why I feel that this quantum computing will be the real support for this 6G from the manufacturer to the network. And it will provide you all the universal programming language. It will the migration of various hardware and software together, as well as for all kind of supporting and interfacings are very easily programmed with the help of this Q sharp. So these are the salient features, which is the functional instruction, rich user interface, modularized design. It will convert the functional instruction to user, as well as it is scalable to the new programming, and obviously our rich dashboard. Dashboards was easily developed in this Q sharp. So this is the direct difference between the classical digital network. Previously I explained with the classical computer, and now I'm moving towards that this quantum is applicable not only for computing, but it is applicable for classical digital network to quantum network. So such kind of comparison is also available. And if we consider in terms of quantum internet, this is the complete roadmap which will provide you, and definitely each of its attributes are again the individual research areas. So we can say up till now I used quantum for the computing, I used the quantum for the networking. Yes, the quantum is also applicable for the security. In a security, that is the quantum security is also applicable in all kind of 6G. And the very first algorithm which I used, I implemented, and I got the result also based on this first algorithm which was introduced, that is the quantum algorithm by Shors. Shors was the first researcher who has presented a long back, again in 1992, the first algorithm for the modular arithmetic, quantum parallelism, and quantum Fourier transform. So everything is there, but applying with a quantum. And this is the smallest explanation that is completely as sir told that, yes, it is the periodic function and it is a x of x raised to a mod n. So complete computation is depend on this single arithmetic. So we'll proceed directly. So this is my small, those who really interested, they can directly contact me. This is the small result I found out. And this is the result. As I told you that traffic flow optimization using quantum annealer. This is the recent publication which I have done. That is preprocessor maps the GPS and find the congestion, find the alternatives, and minimization the model with the help of QPU, that is the quantum processor unit. And then the result is in front of you. That is what will be the result for the traffic flow optimization, and another one is a optimized result. So this is the completely result oriented. So as per my understanding, quantum hardware and quantum algorithm, that is yantra and tantra, is already ready. Only the mantra is remain, because quantum operating system is really a challenge for the future. So this is the quantum internet, small application. Everywhere, anywhere in a worldwide, this QC is there. So you can, through these qubits, you can communicate worldwide anywhere. So right now already in a WhatsApp call, we are communicating to any person from anywhere to anywhere. But these are the base, and obviously QC is applicable for any kind of network communication. So again, the quantum is there. So these are the last area where the quantum is applicable, that is in a quantum security. So any kind of security, that is entanglement, and the inherently is privately secured. So very security, sir has already asked very security. So here you may be get the solution, here is the security. We can apply and we can find out various ways of private, public, all kind of hybrid or any kind of security. So quantum security is again the next research areas which is again open for this 6G. So these are the references, and if anyone have any question, kindly ask. So these are the first qubits. There are only two conditions. Either you won't understand anything or you will get everything. So I hope you will get everything, because the presentation you will find out A. Deshmukh and quantum computing anywhere on a Google. So it is available. You can check it out, and you can, if you are interested, you can proceed for this. But my conclusion is, yes, the quantum word is applicable in computing, in networking, in intelligence, and as well as in any kind of communication. Okay, thank you very much.
A very nice presentation by Madam. Now I request Mr. Vivek Kumar to give his presentation.
Hello. Good morning to all. Can you play my, yeah. I'm Dr. Vivek Kumar from NIET Greater Noida. First, I thanks to Sir Singh sir to invite me here, and I thanks to KIT, and thanks to my beloved Guru Dr. Ramji Prasad. First, I want to take 2 minutes from you. I want to tell you last 2-year journey under the guidance of Professor Ramji Prasad. अभी 2 साल, स्टूडेंट्स प्लीज़ लिसन मी, 2 साल पहले तक हमारा कोई काम फोकस्ड नहीं था रिसर्च में. हम जो चाहते वो करते, पेपर कॉन्फ्रेंसेस पर फोकस थे. देन वी केम टू कांटेक्ट विद प्रोफेसर रामजी प्रसाद. सर ने हमें काम देना स्टार्ट किया तो टेक्नोलॉजी सीखने का मौका मिला और हम ये चाहते थे कि किसी भी तरीके से हम सर को इम्प्रेस करें. हरदम यही रहता था, मैं और हितेश सर, कुमुद मैम, तीनों का यही रहता था कि कुछ ना कुछ हम कुछ ऐसा करें कि नेक्स्ट हर 15 डेज़ में एक मीटिंग ज़रूर होती थी और हम मीटिंग में स्किप कर जाते थे. लेकिन सर मीटिंग में डॉट 2 साल में हर बार मीटिंग में हमें काम मिला है और चैलेंज मिला है और चैलेंज के लिए हमने टेक्नोलॉजी को सीखा और टेक्नोलॉजी इतनी सीख ली कि कंपनी हमें अप्रोच करती है डायरेक्टरशिप के लिए, कंपनी हमें अप्रोच करती है कंसल्टेंसी देने के लिए. डिफरेंट कंट्रीज़ के प्रोफेसर्स, इटली का, ऑस्ट्रेलिया के काफ़ी प्रोफेसर्स हमें कांटेक्ट करते हैं कि हमारे साथ काम कर लो. दिस ऑल आर बिकॉज ऑफ डॉक्टर प्रोफेसर रामजी प्रसाद, क्योंकि इन्होंने हमें हर 15 डेज़ में वो चैलेंजेस दिए और उसको करने के लिए हमने टेक्नोलॉजी को बहुत डीप और जितना हो सकता था उतना डीप सीखा. और इसी का ही परिणाम है कि अभी हमने एक पीबीएल इज़ प्रोजेक्ट बेस्ड लर्निंग एंड प्रॉब्लम बेस्ड लर्निंग का एक फ्यूज़न करके वर्कशॉप मोड में 200 स्टूडेंट्स को मैंने और हितेश सर ने 15 डेज़ 9:30 to 4:30 तक 15 डेज़ मॉर्निंग टू इवनिंग. स्टूडेंट्स प्लीज़ सुनना, मॉर्निंग टू इवनिंग नॉन स्टॉप लंच का 1 घंटा दिया बस. बच्चों ने 15 डेज़ में 4 टेक्नोलॉजी सीखी, आर, पाइथन, टैब्ल्यू और एक का तो नाम ही नहीं जानते थे. फैकल्टी नाम नहीं जानती थी, हो सकता है काफ़ी लोग यहाँ भी ना सुने. नाइम एक प्लेटफॉर्म है, इट्स ए डेटा एनालिटिक्स प्लेटफॉर्म. 15 डेज 200 स्टूडेंट्स, 50 प्रोजेक्ट्स किए हैं और जिसमें से 10% प्रोजेक्ट्स आगे जाएंगे. तो दिस इज़ ऑल बिकॉज ऑफ प्रोफेसर रामजी प्रसाद. ये नहीं हमें स्पार्क देते तो शायद हम भी वैसे ही अपनी लाइफ काटते रहते और चलता रहता और ख़त्म हो जाते. हमें अगर कोई जानता है, आप मुझे जान रहे हैं, मेरी यहाँ पे देख लिया विवेक कुमार हैं, NIT हैं, आप जानते हैं, लेकिन जो मुझे नहीं जानता वो मेरे बारे में क्या सोच रहा है. सर हैं, सर को फिजिकली हम जानते हैं, लेकिन जो इनकी बुक पढ़ते हैं, हमारे यहाँ आए सर इलेक्ट्रॉनिक्स के हेड कहने लगे इनको कैसे जानते हैं, तो भगवान है. मतलब वो ये कह रहे थे कि सर से हमें मिलवा दो एक बार, ही इज़ अ गॉड ऑफ इलेक्ट्रॉनिक्स. तो तब हमें रियलाइज़ हुआ कि यार जिन्होंने इनको नहीं देखा वो इनके बारे में क्या जानता है. तो दैट्स वी वांट ऑल्सो कि हम एक काम तो ऐसा कर जाएं कि हमारे जाने या हमारे होने पर भी हमें हमारे बारे में लोग कुछ सोचें, एक प्रोडक्ट दें. बुक सर चैलेंज के लिए, बुक के लिए बोला है, उसका भी हमने डिसाइड किया है चैलेंज, वो हम लेंगे. थैंक यू. ज़्यादा देर नहीं लूँगा, जल्दी सम अप कर देंगे हम. ये ऑल आर अबाउट 6G. सो कल से 6G का ही चल रहा है. आई थिंक 6G के बारे में सब लोग सब जान चुके होंगे. और ये just a moment. Can you do it in full screen? First slide. First slide. do it from there. Yeah, it's okay. Yes. So we fetch some work from our research paper. So students, please listen and see here. If you want to do work in deep learning, you can get some knowledge from here. Please. These are the 6G band. We did work in terahertz and AMSR2. It's a NASA satellites. From there, we got data, and we did work on that. So we work on channel propagation, channel modeling, smart channel modeling, and it's on D and G band, that is 6G bands. And we have to find some gaps in research. First, if you want to do work, you will have to find out the gaps. So from where you can get the gaps, it's a literature review. If you did literature review well, you can find out the problem. So this is the review part, that all the in previous paper you can find out the spectrum bands work, and then you can propose your work in that. So we did work on 110 and 200 gigahertz frequency bands. Now these are the another literature survey. Here you can see the learning techniques used in previous model and the communication types. There are two types of communication, satellites and terrestrial. So we have given a view of it here. Now you can see the ANN parameter. We did work in deep learning, so we did some work, some literature work of ANN learning models in previous research. So these are the research in previous, and you can see here the references also. And this is the RAIN model mathematics which we have used. That is RAIN attenuation. So we did work on RAIN attenuation. Again, you can see here in previous work how much accuracy came from different research. You can see here. So reference with reference we have shown here in different way. These are the, you can see here the proposed MSc for vertical and horizontal polarization. Again, you can see here R-square comparison. Here are the R-square comparison with our vertical and horizontal polarization. Student, please see here. It's you heard about Keras. How many students heard Keras? Can you raise your hand? No. How many students heard TensorFlow? How many students heard TensorBoard? It's we did integration of TensorBoard with Keras and TensorFlow. So the benefit of that, earlier you saw results was not lucrative. It's a simple result. If you want to publish your paper, if you want to visualize your results, you will have to choose a good tool of visualization. If you are working in Python, with Colab, you can integrate TensorBoard with Keras. So we did work on that also. So you can see here, you can show your result in a better way. You can see here, it's a problem of machine learning. How can you say, how can you compare your results with other? You can compare, but how can you calculate the execution time of your algorithm? It's a problem, it's a challenge. If you do work on tensor board, you can do it easily. You can see here, last point is relative. It's a time. How much time taken by Adam, by RMS probe, by SGD algorithm. There are different optimization in deep learning you can use here, but which one is better, it can show you. You can see here, it's a better result, it's a better view of your results. You can do it like that. So you all researchers are know what is error, what is accuracy, what is MSE, what is R square, everybody knows. But how to show your results, it's hard. Now, this is the comparison of all results. So, we can say SGD optimizer in my results is giving best results. So, for vertical and horizontal, both are here. Now, this is the last but not least. It's a comparison of different already existing model, mathematical model in rain attenuation. So I compare that all models with my model. So this is the end. Thank you. If you have any question, you can ask, please.
It was very short and nice presentation about his work of modeling of different. Now I request Mr. Mandar Biwalkar to give his talk.
Hello, good morning all. First of all, I am feeling very glad to have here and giving a chance to speak few about the 6G. So my presentation will be on application of artificial intelligence in 6G network. Now, these are the contents of my presentation. First, I will talk about why artificial intelligence is necessary in the 6G network and what are the different challenges. Then I will discuss about AI-enabled 6G network services, then role of AI in 6G, and then I will discuss about the 4-layer architecture. So this architecture is similar to the TCP architecture. So then AI technique for 6G network, and finally I will talk about the conclusion and the future research scope. So when we move from 5th generation to 6th generation, why AI is necessary? Basically, day-to-day life we are encountering with smart terminals and infrastructure is developing day by day, and current 4G and 5G networks are not coping with the ever-increasing data traffic. So with the use of AR and VR, the most advanced technology is required, and also we are aware of the remote surgery and holographic projection. So for this purpose, the 6G is required. Then design and optimization of the 6G network can be improved if we implement it with artificial intelligence. And finally, with the improved network of the 6G, we can provide a good quality of service, also a good quality of experience to the end user. Then what are the challenges? The current challenges are about the device energy consumption because 6G will require more battery power. Then machine learning related challenges are there. Terahertz communication challenges are there. And now on the right hand side, you can see how artificial intelligence can resolve these different challenges. First one, it can provide mobile edge computing, intelligent mobility, better handover management, and the smart spectrum management. Now, when we think about the 6G services, the first service it can provide that is knowledge discovery from physical environment, then smart resource management, automatic network adjustment, and intelligent service provisioning. Now, achieve this objective, that is of providing the good services for the 6G, the four-layer architecture similar to the TCP is proposed. So the bottom layer is about the intelligent sensing layer, which basically collect the raw data from the physical environment. So basically, if we use a drone, then by using a drone, we can collect the raw data from the physical environment. Now, this data will be in large in amount. So to process that large amount data, will require the data mining and also the analyzing it. So the second layer is about the data mining and analyzing. Then intelligent control layer is there, that is third layer, and finally the smart application layer, which gives you the actual application of the 6G. Now, when we think about any mobile network, from second G, third generation or fourth generation, what are the major requirement is better data rate, end-to-end latency. So all these things we know. And also this we can achieve in different scenarios such as enhanced mobile broadband, ultra reliable low latency, and machine type communication. And to achieve this, the different supporting device services are there, such as millimeter wave and massive MIMO, and device-to-device communication is already implemented in 5G. But when we come to the 6G, where the implementation of AR and VR is there, the more intelligent network is required. Now, I like to play a small video where you can get what is the role of these three different scenarios in the 6G. So can you play the video from there?
Radio communication turned its first page when Marconi transmitted the first radio signal across the Atlantic. With the endless frontiers of wireless, spanning 5G, we start wondering what 6G would be like. 6G will serve as a distributed neural network for future intelligence of everything. Network sensing and native AI will become two new usage scenarios to fuse the physical, biological, and cyber worlds, leading to an era of connected intelligence. 6G will provide universal high-performance wireless connections with speed comparable to optical fibers. Terabits per second peak data rate, up to 100 gigabits per second user experience rate, and sub-millisecond level transmission latency will enable truly immersive human-centric experience. Further integrating terrestrial and non-terrestrial networks, we can see, touch, smell, and play with family and friends from thousands of miles away, even in the sky or in outer space. 6G will accelerate full-scale digital transformation of vertical industries. In future automated and flexible manufacturing, precise localization and deterministic communication will be provided to support real-time interaction between collaborative robots. A rethinking of network architecture is also considered necessary to enable massive machine learning and knowledge sharing among robots. 6G will continue the journey of connected everything initiated in 5G, but with larger variety of devices, new human-machine interfaces, higher density of connections, and native trustworthiness. 6G will integrate sensing with communication in a single system. Radio waves can be exploited to see the physical world and make digital twins in the cyber world. Such capability offers autonomous driving vehicles ultra-high resolution and accuracy in all weather conditions. What's more, high precision localization and gesture recognition will truly free our hands and make art creation anywhere, anytime. 6G will boast its native AI capability. Deep Edge architecture enables massive machine learning in a distributed and collaborated manner. Robots can thus harmoniously work and play with humans. Meanwhile, end-to-end machine learning will also be leveraged for customized optimization and network automation. 6G is the next horizon of innovations. The ambition of our 6G vision is to make our planet intelligently connected, sustainably developed, better protected, and full of vitality in all walks of life. 6G, the next horizon, from connected people and things to connected intelligence.
So actually I have played this video because the students are there. Most of the researchers may know what are the applications of the 6G. Now when we think about this complicated 6G, the requirement is also very high. That is high peak data rate, latency, and everything is there, is available in the book. So I will not talk about much about it. This is a role here. You can see we can sense the raw data from three-dimension world, that is underwater, ground network, and from space. So from all the three scenarios, we are collecting a large amount of data. And why AI is required? First of all, think that AI can provide a strong learning ability, powerful reasoning ability, and intelligent recognition ability. So these are the well-known things which we know what AI can do. The second thing is that AI-enabled techniques were applied to achieve intelligent network. Just now in the video you have seen that intelligent networking is required. And if we gather a lot of data from different sensors, then intelligent networking is required. And lastly, the deep and reinforcement learning will give you the automation as well as the fast learning about the network. Now, using this information, this four-layer structure, how it works. If you see at the bottom layer, basically the data collection is from the different devices, then data mining, and actually analyzing of the data we are doing at the second layer. Then at the third layer, intelligent controlling, that is by using some optimization technique like genetic algorithm or any other optimizing algorithm, we are optimizing the network for better mobility as well for better handover. And the last layer is the smart application layer, where we can see the different applications in the smart city, smart industry, as well as in the medical field. Now, first layer, that is bottom layer, what it is doing? It's actually collecting a raw data. Now, how the AI play a major role? Here you can see the most popular algorithm, that is CNN, which can sense accuracy with low complexity. So it can sense the data from lot of sensors with low complexity. Then another algorithm that is came in clustering and SVM, support vector machine. They can real-time sensing the training low-dimensional input samples. Bayesian learning will provide data fusion, and SVM and DNN, that deep neural network, basically classify the whole data into two classes. One is the ideal class, and the second one is the bi-class. Now, actually the different layers are there. The second layer, basically the core task is to process and analyze the massive data. Also, here at this layer, we are using two algorithms. One is the principal component analysis for dimensionality reduction. Okay. Why dimensionality reduction is required? Because when we collect the data from many sensors, actually the dimensions are very high. So to reduce that dimensionality or to actually compress the data, we required PCA algorithms. Then data analytics is required, and then intelligent control layer for optimizing and decision making. Then last layer will give you a better quality of service and quality of experience to the end user. So this is our four-layer structure which is proposed for the 6G network. So this is actually the overall 6G network. Here the bottom layer is the edge computing server, which is a low actually capable processors. So actually only the basic algorithms or light AI algorithms we can execute at the bottom layer. Then cloud server will have a higher processing capability where we can actually execute the high-level algorithms of AI. And then this is the different services that is important mobile edge computing. The mobile edge computing, now yesterday one speaker have told that edge computing, why edge computing is required? Because we are getting the data from a number of sensors and interface is required to put that data on the cloud. So better mobile edge computing is required that artificial intelligence can provide. Then second one is the intelligent mobility and handover. It is also provided by the AI, and which particular algorithms are playing a role. The recurrent neural network and artificial neural network, they are playing a major role in the better handover management. And lastly, the STM algorithm will play a major role for better, actually future mobility context. And it is comparison. Actually what AI algorithms are doing, they are actually doing a comparison from the previous data to the next data. And from that comparison, they are taking a best result, and that results we will actually pass on to the next layer. So actually spectrum management also we can do with the artificial intelligence. So here you can see 6G uses different frequency band from millimeter wave to terahertz, and that's why the actually the device will be more energy, will require more energy. Then second one is the framework. First modules actually takes, here you can see the hidden layers will take the data from the number of sensors which is there on the top from radio, micro, millimeter, and then we are doing a training at this middle layer, and after the training we are optimizing the data and we are passing to the different devices for better mobility as well as for better performance. And this is the conclusion and future scope. Just now I have discussed about the different scenario for the AI, where we can implement the AI in the 6G network. In the future scope, actually better computational efficiency and accuracy is required. So AI learning scheme is, better AI scheme is required. The second one is the robustness, then hardware development and energy management. So these are the areas where we can do a future work. And finally, apart from the only using the simple AI algorithm, if we do a physical modeling, okay, from physical modeling we can improve the performance of the AI. So the next after the AI is introducing the different physical model to improve the performance of AI. That is the next future scope. These are the references. Thank you.
Thank you, Mandar. He has given a very nice insight into 6G, how it can be enabled with the AI. Now I request Jyoti Gangane to give her speech.
A very good morning to you all. Thank you. Honorable Dr. Ramji Prasad sir, today is our chairperson, Colonel Rao, all the colleagues and my dear students. I am Dr. Jyoti Gangane, currently working as a professor and head in Vishwaniketan's Institute of Management, Entrepreneurship and Engineering Technology. I did my PhD under European Union's project, EMACW, which is under CTIF Global Capsule. For that, I'm very much thankful to Honorable Dr. Ramji Prasad sir and our Vice President, Dr. Inamdar sir. They deputed us to complete our PhD from University of Malaga, Spain. I worked on 4G at physical layer, that is performance of single carrier FDMA for land mobile satellite channel. I completed my PhD in 2016, but because of some personal reason, I went to administration. I lost my research connect link. So today I'm here again to start my research topic. So whatever I'm going to present today, that is aerial radio access networks towards a comprehensive 6G access infrastructure. This is just an informative presentation because I'm going to start from the basic. So that's why I joined Vishwaniketan. Vishwaniketan implements project-based learning. We do course level PBL, technology PBL, and industry PBL. With this short introduction of mine, I will start my today's topic. That is aerial radio access networks towards a comprehensive 6G access infrastructure. This is the outline of my presentation. Introduction, key features of 6G, aerial radio access networks, and system architecture of ARANs, and conclusion. First of all, I thought I will work how AI/ML is going to help in physical layer. If at the transmitter side, we can implement the algorithm which will inform you about the channel condition. That we did using adaptive modulation and coding while doing the 4G. But since yesterday, I heard many researchers' presentations. They talked on AI, ML implementation, role of AI, role of ML in 6G. So very good presentations yesterday I heard from Dr. Mantri sir, Dr. Vandana Rohkale, Dr. Kumud, and today Aradhana Deshmukh, and so on. So as compared to them, my presentation will be a very basic, but this is also very good technology which we need in 6G. Everybody know what is 6G. I'm not going to in detail of that. But with this figure, if you see 1G FDMA, 2G TDMA, 3G WCDMA, 4G OFDM, and 5G OFDM millimeter wave, and 6G again OFDM based new waveform. So you will observe whenever there is a change from one generation to second generation, we are changing the software, modulation techniques, and hardware. So this cost operator has to bear. So what is 6G in all? 6G will be combination of new technologies and enhancement to bring a big gain. I don't want to talk much about on 6G because we heard from many of the researchers what are the advantages and why we go for 6G. Here are there some key features of 6G: multi-band, ultra-fast speed transmission. This can be achieved with the help of T-Hertz band communication and visible light frequency band. Then energy efficient communication is a second key feature. Harvest energy from ambient radio frequency signals, harvest energy from microwave vibrations, harvest energy from sunlight, and wireless power charging. So with the help of this, we can save the energy, we can charge for our batteries. Then artificial intelligence, operational intelligence, environmental intelligence, and service intelligence. Then high security, secrecy, and privacy. Already Aradhana madam talked on quantum computing, well-known integrated multi-level security, quantum key distribution via visible light communication, and blockchain technology. Then what is aerial radio access networks? It is called as ARAN. Already we know RAN, R-A-N, radio access networks. So current network access infrastructures are characterized by heterogeneity, low latency, high throughput, and high computational capability, enabling massive concurrent connections and various services. But unfortunately, this design does not pay significant attention to mobile services in underserved areas. What are those areas? In case of flood, earthquake, where your terrestrial mobile towers will not be there, so they may be destroyed. In that case, we can have this aerial radio access networks. So the use of aerial radio access networks, ARAN, is a promising strategy to complement existing terrestrial communication systems, so involving airborne components such as unmanned aerial vehicles, drones, and satellites. So ARANs can quickly establish a flexible access infrastructure on demand. It will work like ad hoc networks. different devices coming together. Already in wireless network, we know about ad hoc networks. Then ARANs are expected to support the development of seamless mobile communication system towards comprehensive sixth generation global access infrastructure. So there are some fundamental features of this ARAN: ubiquity, where the LEO communication tier guarantees service continuity across the globe with 3 advantages, including wide coverage, networking backup, resilience, and emergency broadcast, for which the terrestrial infrastructure has limited capacity. This is one of the feature of this ARAN. Then mobility, the dynamicity of aerial, low aptitude and high aptitude topology implementation, and the networking overlay among the LAP, HAP, and LEO communication systems help ARANs to adapt flexibility to the requirements of the end users anywhere on the ground and in the air. Third feature is availability. Operating in the air at various altitudes, ARANs are not commonly affected by natural and man-made disasters, capable of rendering terrestrial communication infrastructures vulnerable and interrupting service. In other words, better service availability is provided regardless of the recipient's terrain, mountain, sea, deserts, etc. Then simultaneity, multi-tier, it is having low aptitude platform, high aptitude platform, and LEO communication systems can adaptively self-organizing to forward information-centric services effectively across the discrete and locations on simultaneous multicast and broadcast streams using various wireless access technologies. Scalability, because of aerial base stations interlinked to each other using aerial, wireless, and ad hoc technologies, and there are hierarchical networking overlays among the LAP, HAP, and LEO communication tiers, ARANs can quickly establish a scalable topology for the local sites without service interruptions. So ARAN in 6G access infrastructure, you can see core of the earth, underground RANs, underground water communication, then terrestrial communication up to 100 meter, low altitude platform LAP from 0 to 10 kilometers, high altitude platform HAP 20 to 50 kilometer, and low earth orbit LEO communication, that is from 500 to 1500 kilometer. Then ARAN in 6G access infrastructure. Already ARAN encompasses 3 systems, including, I already told, low aptitude, HAP, and this. So there are some related terms with this aerial communication. DRAN. The DRAN architecture belongs to LAP. DRAN stands for Drone, Unmanned Aerial Vehicle, Assisted Radio Access Network, where drone helps to extend the coverage area and capacity of terrestrial access infrastructure. In this context, drone can connect either directly to terrestrial base station or via head node in the multi-hop, mesh, or star, tree, and chain topologies. The application of DRAN is aerial surveillance, smart farm, smart city, environmental studies, and temporary capacity boost. Then second is FlyRAN. This FlyRAN stands for Flying Radio Access Network, where aircraft and airships equipped with radio transceivers, they are utilized as aerial base stations to provide mobile services in unserved. A tier typically exploits the license spectrum to avoid unmanaged conflicts with the terrestrial systems. And application is remote populations, rescue and surveillance environment, studies temporary capacity boost. Then STIN represents the satellite, terrestrial, integrated network by which satellite communications support the terrestrial system to offer global, seamless, and ubiquitous internet. It is used in isolated populations, emergency and alarm, global roaming, large-scale Earth studies, etc. The last one is ARAN. It is referred to as multi-layer and hierarchical aerial access infrastructure combining FlyRAN and LEO communication systems. So this is the system architecture of ARAN. It is divided into 5 parts. First one is the core, backend interface, main segment, front-end interface, and user. So we can see this thick line is for satellite link, and this dotted line is for mobile link. One by one we'll come to each segment. You can see at the bottom layer you have low altitude platform, high altitude platform, then LEO, CubeSat, LEO layer 1, LEO layer 2, and communication satellites. So ARAN architecture comprises a main segment, as I told you. It is a cross-tier networking infrastructure shared among the aerial base stations at the LAP, HAP, and LEO altitudes. A front-end interface providing terrestrial and aerial access points that gather user connections, and a back-end interface bridging RAN infrastructure to the terrestrial core. It's not able to go back with this. Next. So as I told you, LEO communication systems use satellite links to contact the terrestrial network through ground stations, while low altitude platform and high altitude platform systems use mobile wireless links to contact aerial base stations and the terrestrial base station, example G node Bs and E node Bs directly. Then in the main segment of the ARAN, LAP systems are at the lowest tier, as if you recall the figure. I'm not able to go back with this. So in the main segment of RAN, you have LAP systems that are at the lowest tier, drones and unmanned aerial vehicles. In LAP system acts as a aerial base station, providing connectivity directly to the aerial and terrestrial end users, or remote base stations using wireless technologies such as 5G new radio and Wi-Fi. Conversely, these aerial base stations may utilize either satellite technology to connect with LEO communication system or wireless technologies to the terrestrial macro base station or backhaul transmissions to the core network. And low altitude platforms can be classified by size, range, speed, and endurance. According to the US Department of Army, the LAPs are classified into 5 categories, that is small, less than medium, large, less than large, and largest group, greater than larger. Most LAPs are relatively lightweight and cost-effective device that can be deployed quickly and flexibly. High altitude platform systems mostly utilize satellite technology via LEO communication systems. In practical situations, some industries have implemented trial projects using lightweight solar-powered aircraft and airships to provide stable broadband services in rural and remote areas. At the top of the LAN, if you recall the figure, we have different LEO communication satellites, that is CubeSat and ComSat. Systems consist of miniaturized satellites below CubeSats and communication satellites above, orbiting at an altitude of 500 to 1500 kilometers. CubeSats aim to provide low latency and high throughput internet services, while ComSats are designed for high coverage and service availability. These two LEO layers interact with each other through interlinks, which provide redundancy, backup, and collaboration interfaces for the dynamic network organization. Compared with the other satellite classes, LEO satellites are characterized by lower latency, cost efficiency, and quick production and deployment. Most LEO satellites operate on Ku, Ka, and V bands to provide internet connections to aerial and ground stations with tens of milliseconds latency. So unlike these low altitude platform and high altitude platform systems, LEO communication systems typically do not provide services to the end users directly. So the second segment is in the ARAN is the front end interface, which includes aerial base stations at the low altitude platform and high altitude platform tiers. Remote base stations and ground base stations are enabling end users network access the network. Then aerial base stations and remote base stations are ARAN access points that provide the wireless link direct to the aerial and terrestrial users. Meanwhile, the ground stations are the endpoints of satellite links from LEO communication systems that deliver the traffic to and from the remote base stations. Depending on the prevailing circumstances, the aerial base stations and the remote base stations may cross-serve both for the aerial and terrestrial services. Conversely, the back-end interface includes the macro base station, which was in the diagram at the left side, and ground stations to accommodate backhaul traffic toward the core networks, typically the micro base stations with the transfer of traffic flows from the low altitude platform systems, while the ground stations support the traffic forwarding from the high altitude platform systems. LEO communication system, the right side in the figure. So, ARAN architecture provides a heterogeneous communication capabilities from the multiple tiers with distinct functionality and features. As a result, ARAN supports a broad range of emerging applications and services such as wireless coverage expansion, aerial surveillance, precision agriculture, and commercial delivery. So this is a short presentation from me because as I already told, I'm going to start my research from this point today, and thank you very much.
So thank you very much for listening all the speakers. It's slightly late. Culprit is me, I know, but still, thank you very much for bearing with us. Now, very interestingly, these speakers have told you the insight into what we can expect from 6G. I believe there is work going on 7G also now, I hope, read somewhere. Madam, the last speaker, the Gangane madam has given insight into aerial communications, which is very close to me as a defense personnel, because a lot of UAVs and drone warfare is going on, and it will be a future of warfare now. So that is what very interesting what I have found out. Then the Mandar sir has given the insight into AI. Other than chatbot and all, ChatGPT, what AI can do with the help of 6G. One interesting thing he has mentioned about AR and VR. VR is the future for display now. Whatever training we do in defense is in VR labs now. I have tasked by as Dr. Ramji sir always say you should give the challenges. So I have already given the challenge to my people in KIT. We have already established AR VR lab. Next time, sir, we will show you what we have established AR and VR for our students to have the cave VR. Cave VR is basically a phenomenon where we can have the same VR scenario with multiple users. It is again heavily, what do you call, communication based. And so that was very interesting, and with the AI, what wonders we can achieve with the help of 6G. And Deshmukh madam has given the different flavor of mythology to it, Tantra, Mantra and Yantra. From this I just remember there is work going on, and it is very challenging. You have seen the depiction of the various astras used in Ramayana and Mahabharata. This Brahmastra and Vajra and Pavanastra and all. What they used to do, what is the depiction, visual depiction of these throwing off these or launching of these weapons. They aim it at sky and then direct it and hit it. There is no storage of that particular. So those are energy weapons. You have to have the technology to hit and collect that energy which is available in cosmos, and you have to just reflect it point blank. So that is the next weapon system. Work is already going on. This is a very secret project. I should not have mentioned it, but रहा नहीं गया, मैडम ने वो तंत्र मंत्र बोला तो. So, and with the help of 6G and 7G, that will be a backbone to get it here and reflect it. Precision with the precision is a challenge. So thank you very much. Listening calmly and patiently to all the speakers, and especially me, which doesn't have so much insight, but still I was made the chair, so I have to behave like that. Thank you very much.
Thank you, sir. Now it's time for the coffee break. So I request everyone to go outside. We will start next session after sharply at 12 p.m. Thank you all.